This is section 11.4 of geometry. Today we have a new formula. It still builds off old ideas that we already know, but our formula here is going to be the formula for the area of regular figures. Remember that regular figures must have all of the same figures. Every side is the same length, every angle is the same measurement, okay? If you'll notice in your book on page 440, they show you a kaleidoscope. They show you how a figure might be inscribed inside of a circle. Remember, when it's inscribed, every vertex is on the circle, all right? So here we would have a square. Because it's a regular figure, we know that the lengths of all the sides are congruent. We know that all the angles have to be congruent. Now, because it's inscribed in a circle, there are 360 degrees in a circle. So if I draw a radii in here, I can separate my figure into triangles. All right, this is 360 degrees. It's going to be divided 4 ways because there are 4 sides in the figure, and that's going to give us 90 degrees. Now, this 90 degrees does not refer to what we have down here. It refers to the angle created in here. Each one of these is going to form a right angle. Now, in order to find the area of these figures, we have a formula, 1/2 AP, all right? And again, this only refers to regular figures, regular polygons. 1/2, of course, is 1/2. A is going to be the apothem, okay? It's a short A, apothem. It's a word you need to be familiar with. And P will give us our perimeter. Okay, so the perimeter of the figure that we're trying to find, in this case a square. It might be, if you look in your textbook again on 440, they show a square, they show a hexagon, they show a decagon. It could be any regular figure that this will work for. So if I find my angle in the center, I need to find the apothem. The apothem is going to be the length from the center perpendicular to a side. So it's not going to be a radius, it's going to be the line that I draw right here. Now, because these were radii, these are isosceles triangles, and anytime we divide an isosceles triangle, it splits the base in half, it splits the angle in half, and it's perpendicular to the base. So since this was a 90-degree angle, now we have a 45-degree angle. Here we have a right angle, so this is also 45 degrees. So we have a 45, 45, 90 triangle, okay? And we know something about the measure of those sides. So once we figure this information out, then we can apply it here, 1/2 apothem times perimeter. So working the triangle, I don't have any values yet. We're going to see some in just a minute. I can find the apothem. I can find the perimeter of the figure that we're working with, and I can multiply those together and take half of them. All right, so you have examples in your book, but I'm going to work a few of them as well. We're going to start with a regular hexagon with an apothem of 6, okay? So I'm given several things here. I have a regular hexagon, and we're told that the apothem is equal to, let me confirm, to 6. Okay, now a hexagon is a 6-sided figure, but you can see here all we really worked with is this. So I can go ahead and draw my triangle. Now keep in mind, this is part of a hexagon that's going to continue on around here. If I don't know, I may end up with a 1, 2, 3, 4. Yeah, we're close. Okay, but this is all we're concerned with, and we are given in this case that the apothem is A. Now remember, this is assumed to be inscribed in a circle going all the way around. We're just looking here. The apothem is 6. If I want the perimeter of the figure, I need to find the base of the triangle and multiply it times 6. So this is what I'm working with. Now a hexagon has 6 angles or 6 sides, whichever you will. Sides. All right. Since it can be inscribed in a circle of 360 degrees, I can divide that by 6, getting 60 degrees. That means the measure of the central angle here is 60 degrees. But we have gone ahead and divided it, drawn our altitude. So we will be working with 30 degrees here, 60 degrees here, and a right angle. I know the long leg is 6, so the short leg we need to, this is the long leg to the short leg, I'm going to have to divide by the square root of 3. Now I'm not really concerned with the radius, so I don't have to do that, but that means that this entire length is going to be 2 times 6 over the square root of 3, or 12 divided by the square root of 3. Rationalize your denominator. 12 square roots of 3 over 3 gives 4 square roots of 3. So each side is 4 square roots of 3, and it's a hexagon, so we have 6 sides. So the perimeter will be equal to 6 times 4 square roots of 3, or 24 square roots of 3. Now, perimeter we need for our formula. A we need for our formula 1/2 the apothem times the perimeter. So we're going to finish up here 1/2. The apothem is 6, and the perimeter is 24 square roots of 3. So doing the math here, 1/2 of 6 gives 3. 3 times 24 is going to give me 72 square roots of 3, and that is going to be my area. So once again, regular figures, they're going to be inscribed in a circle, so we will always be working with 360 degrees. We're going to find the measure of the central angle right here by dividing 360 by the number of sides. So in a square, 360 divided by 4 gives me 90. In my hexagon, 360 divided by 6 gives me 60. That's the measure of the central angle. We're going to divide the central angle to create a right triangle, because that's what we know how to work with. All right, and then we're going to proceed to solve the little triangle here. Now, what you have to remember is the length of a final side is always going to be double whatever we find here, and then we're going to put it into the formula. All right, you'll find instructions on how that works on page 440, 441, and in my notes as well. Now, if you will look on page 442, sometimes our central angle will not come out so pretty. We won't have a 90 degree or a 120 or a 60 or a 30. There you'll see a 20 degree angle, okay? So a 20 degree angle, if this is 20 right here, I will now have to be working with my sines and cosines. Again, this is something that you should know how to do. You can look at their example on page 442 to get a good idea of that, all right? If you have trouble, you can contact me through my schoolworks, but if you memorize the formula, if you work the triangle very carefully, you can find 1/2, you can find the apothem, you can find the perimeter, multiply, keep exact values, okay? Reduce your radicals, reduce your fractions, but don't use decimals unless you've had to use sine or cosine, or unless you're told to specifically. All right, thank you.